Hello and welcome to another video with Leah. Today I'm going to be drawing the Lewis structure for water, H2O. In order to draw this Lewis structure, we need to know its formula. So it's made up of 2 hydrogen atoms and 1 oxygen atom. Next, we're going to count the valence electrons in water. So each hydrogen has 1 valence electron, but there are 2 hydrogens, so there are 2 valence electrons for the hydrogens. And then we add 6 because oxygen has 6 valence electrons. In total, we have 8 valence electrons. Next, we're going to draw our skeletal structure. So that means we're going to draw the central atom and attach the 2 outer atoms. Oxygen will be our central atom, and attached to this we will have our hydrogens. We know that oxygen is going to be the central atom because a hydrogen can never be a central atom. Okay. Next, we're going to see how many valence electrons we already used, which we already used 4 because we made 2 bonds. And now we're just going to figure out how many valence electrons we have left to use. 8 minus 4 is 4, so we'd still have to draw 4 more valence electrons. And these are usually drawn on the outer atoms first and then on the central atom. Now, as hydrogen cannot be drawn with any lone pairs, we're just going to put these 4 valence electrons that are left over on the oxygen atom. So now we have no more valence electrons to use. And now we're going to check that the octet rule has been fulfilled by these atoms. So for each of these hydrogens, we see that they have 1 bond to oxygen, and that makes them happy. So they are satisfied, because in Lewis structures, hydrogen only needs to make 1 bond to be satisfied. It's not going to be holding 8 valence electrons. It will only have 2. Next, we look at oxygen. So we see oxygen here has 2 lone pairs, okay, these dots around it, and it also has 2 bonds. Knowing that each bond is 2 valence electrons, we know that oxygen has fulfilled its octet rule. Okay, so there are 4 electrons here, and then 4 more here. And so this will be the Lewis structure for water, H2O. Now looking at this structure, we can answer a few questions about it. What is its shape? Well, considering that it has 2 lone pairs and 2 bonded pairs, we will call this a tetrahedral, shape for the electron pair geometry, and we can say it's bent for the molecular pair geometry. Okay, so the electron pair geometry is counting the lone pairs and the bonded pairs, and the molecular geometry is only counting the bonded pairs. And we can say that it has 2 lone pairs on the central atom and 2 shared pairs that connect to the central atom. So it's a good idea to know how to find its electron pair geometry and the molecular pair geometry, and to know how to count the lone pairs and the number of shared pairs.